So tonight we have Mike Fisher and Marty Abbott. Mike and Marty have a special place in my heart here at Etsy. When I joined Etsy in September 2008, I was still sleeping on an air mattress in an apartment in Brooklyn. I just moved here from the Bay Area. And Marty and Mike run a consulting firm called AKF Partners. And I'm going to maybe tell their bios a little bit. Mike was CTO at Quigo, the advertising company acquired by AOL. Before that, was VP of engineering at PayPal. And Marty was, and this is Mike. This is Marty.
I'm the good-looking one.
Yeah. So Marty was COO at Quigo along with Mike and was CTO at eBay. So in my early days at Etsy was much, much smaller. We were in a really almost disturbing building about a mile and a half that way. And so having the former CTO of eBay and VP of engineering at PayPal come visit and do some consulting for us was really helpful. It was literally my third week at Etsy. And I feel safe saying this now. After their visit, we did a wrap-up meeting, and Marty and Mike looked at me like, oh my God, you're never going to fix this. So I think we've actually done pretty well. So tonight, Marty and Mike are going to be talking about Scalability Rules, which is the name of their book. Heather back in the corner there is actually from Pearson, is selling copies of this book at 20% off, credit card only, which is a rare thing in Brooklyn. Most Brooklyn business is done only via cash, but $23.99. For the online audience, you can submit questions at etsy.me/onlinelabs. So check that out if you're online. I guess if you're watching online, you're already online. So, but with that, I'll hand it over to Marty and Mike. Thank you.
All right, well, thanks. Is this on? Hear me now? Thanks for having us out here. We are huge fans, by the way, of Etsy and the work that you guys have done. I don't remember telling him that you guys would never get it fixed, but nevertheless, and it's not just us, by the way. One of the things you guys should hear, how many folks here are actually from Etsy? You know, you have an incredible following throughout the tech community. Oftentimes when we go places, how cool do I look with all this buttoned up, by the way? Oftentimes when we go places, they'll ask us questions about you, and we're not ashamed of telling them, you know, that you were at least at one time a client, and of course take credit for everything good that's happened. But it's, people know about the tech team here. You guys have done an incredible job, not just in turning around technology, but you're recognized as having great people, and that's very important. If you've ever read our first book, we think that's one of the most important things within a technology organization. And in building great technology. A little bit about our partnership. There's three of us totaling 60 years of experience. I have one of those years, and the other 59 are divided between the other two partners. Two published books, both through Pearson. We're working on two more right now, one general business book and one following along the lines of Scalability Rules that's, at least the working title is called Availability Rules. Our business, over 200 clients and counting in 7 countries. The country counter goes up by 1 in a month with our first trip to Tel Aviv. And the most important client ever, right around in this area. Unless, of course, any of the rest of your companies are up there, you're important too. All right, so first some key points. Just overall, our view, availability is not a metric. It's a feature. And when you do what we do and what Etsy does, it's the most important feature of your site. It's table stakes for being in the game online, whether you're a SaaS company or a commerce company. It's not something that's nice to have, it's an absolute must-have. It's dial tone for your company. Scalability is a journey and not a destination. It's not something you pay just once, but something that you have to continue to pay over time. Within the concept of technical debt, we often say a component of that, depending upon how large it is, and it varies by company, is scalability. Driven oftentimes either by the rate of growth of your site or the rate of growth of your code base. Both of them can affect scalability, and you have to address that debt over time. Failure to make that investment is a guarantee to fail. But it's not just about technology. Technology alone is not enough. You need the right person in the right position at the right time with the right organization structure. You must have the right processes, and together, working closely together, and that's not to say, by the way, that processes are the most important thing. They're equally important. And it's the right amount of process, right? Not like Six Sigma type process. The rate or amount of process that you need by company changes with the size of the company, transaction volume, size of the code base, size of the organization, et cetera. And then finally, the right architecture. So some of the rules to follow, Fish is actually going to start.
Sure, so we've selected 6 rules from the book that we're going to cover tonight. 3 are from Chapter 6, which is about caching and using it aggressively, and then 3 are about designing fault tolerance. And so I get to start out by trying to convince everybody here tonight that you should be lazy. And I'm going to ask a question about what's the easiest way to scale a system. And in my mind, that's simply to not have the traffic. And there's 2 ways that we can accomplish that. We can drive all of our users away with no availability and slow performance, although it's probably not great for our evaluations. Or we can let other systems stand in for us. And that's primarily what we're going to talk about tonight, the first 3 rules about caching. The other reason that caching is so important, besides for scalability, it makes it a lot easier, it's also important for performance. Many of you are probably familiar with some of the Google white papers that were out there. One of them stated that when they saw 100 millisecond to 400 millisecond latency, the number of searches dropped by 0.5%. There was another, at a talk this week, a gentleman, Brian McQuaid, who's an engineer at Google, said that DoubleClick found by decreasing 1.5 seconds, they got a 12% increase in click rate. So, and there's a lot of academic research around this area. There's a paper, 2004 by Rose, that focuses on this, that we know it's very important to your users, and it's growing every day. There's a survey done on mobile users, and if you're mobile developers, you think, well, I get a pass because I can blame it on the carrier, that's quickly going away. People expect the mobile space to be just as quick as online. So it's important. And luckily, in a normal SaaS application, there's a bunch of places that we can take advantage of caching. I'm going to point out a few, such as the user's operating system, their browser, their ISP, a CDN, reverse proxy caches, and key value stores. And of course, there's more. Start out talking about CDNs. And CDN is a content delivery network that stands in for you to serve objects off your page. Typically, these are your static objects, like your CSS, your JavaScript, although CDNs can do dynamic pages as well. And CDNs are simply comprised of a bunch of computers that they call nodes or edges connected on a network they call backbone. And they put these edges out on the tier 1 network so that they are geographically closer in proximity to your users. So when a user makes a request, it doesn't have to take 10 hops and cross 3 countries to get to your servers. It can simply be handled by this. They're simple to set up for those of you who have not had that experience using CNAMEs and DNS. And then your servers become the origin servers. So when the content needs to be refreshed, the CDN is requested from your servers, and you simply respond to the CDNs that then cache for you. Yeah. As I was thinking about this rule on the flight out here, I can't think of really any major player in the space that doesn't use some CDNs. Some of them use multiple for various reasons, whether going across Europe or Asia Pac. So it's really important. Some of them can be very expensive, but something that's very important to offset from both a performance and a scalability. Next rule that we're going to talk about is use of expires headers. So there's a common misperception that the page itself can control its caching through meta statements in the header section, such as Pragma, stuff like this. The truth is that those are simply recommendations, and they can be ignored. So a much better way to ensure that your pages and objects on there can be cached is to use HTTP headers. And the way to do this is either through server configurations or through code, and we go into a lot more detail about that in the book. Suffice it for this evening to say that you can set them there. The expires header, the entity field itself, is simply a date and time in which the object expires. So we usually recommend that you set this out, depending on the object, 30, 60, 90 days, potentially a year in the future. And then the question that usually comes up is, okay, but if I want to change my CSS file, do I then have to wait 90 days just to clear everyone's cache? And the solution to that is simply to add some sort of versioning number in the name of the file. And then as you change it in your page, the browser says, I don't have this file, and it goes and gets it. So you don't have to worry about setting these things really far in the distance if you have something like that worked out that you can simply clear them. The other one that we talk about in the book is cache control. And the cache control field, according to RFC 2616, section 14, the directives in that must be adhered to by any caching mechanism along the response request chain. So there's a bunch of things that you can place in there. The most commons that we see are either private and public. And so placing private in there means that this object is only intended for a single user and can only be cached by them. Public, of course, means that it can be cached by any caching mechanism. And so we generally recommend that you set these at public. And you'd be very surprised at how often this is not done in both of these. And if you don't believe it, check your sites. Typically, engineering teams are very focused on getting the next feature out. The ops teams are worried about deploying that and keeping sites running and stuff. And there's very little focus put on stuff like this until it starts to become a problem. We had a client that serves a really large amount of content, and their homepage loaded in 35 seconds. So back to this performance issue that research was showing that anything above 4 seconds, users start degrading their browse and their search. So imagine what users do at 35 seconds. The nice thing is that a few simple tweaks, getting some of the objects off the page, they're able to reduce that to about 7 seconds in literally a matter of about 2 weeks. So very simple to do, but very important. And then finally, if that request gets through off of your user's browser, through the CDN, all the way back to your system, there's still one line of defense that you have before it hits typically your most difficult object or part of your system to scale, which is your relational database. And so this is a key value store or object cache. There's a bunch of them out there, from memcached to Redis, and these are in-process stores, typically in memory. They scale typically very nicely, and they're often used in front of the database. They can be used other places. They can be used for lots of other object cache, between tiers or in services on your website. One of the largest users of memcached is Facebook, of course. In 2008, they announced that they were using over 800 servers of memcached, serving about 28 terabytes of memory. So that was 3 years ago. When they had 10,000 servers, I think they're claiming 60,000 or something now. So imagine how large this has gotten. So another great way to scale, by using object caches. One thing that I did want to point out was, caches are great, especially in front of your relational database. If that thing were to go away for some reason or invalidate the cache, all that traffic comes back to your database. And so warming up the cache, or if it gets invalidated, it can be a big issue. In fact, Facebook found that out about 6 months ago when they pushed a bad config file, and all the requests saw that it was invalid and came out to the MySQL database trying to refresh that, and they had some issues. So something to think about. It's certainly wise to use these object caches, but pay attention to how you're going to warm up this cache and what are you going to do in the event that it goes away. Now we're going to talk about designing for fault tolerance.
We often tell our clients that when you're designing systems to be highly available, the best question to ask isn't how you want the system or platform or technology to work, but rather how you want it to fail. Just about anything that you're ever going to design, or I would say anything that you will design or implement in your life, ultimately is going to fail, right? So we should be thinking about how it is that we want our products to fail, when they fail, right? And fault isolation is a mechanism to ensure, or a way of thinking about things to ensure that once you get a service within your architecture, once it starts to fail, or more importantly, slow down, because very often we can't handle slowdowns as well as we can failures. How is it that you're going to isolate that failure such that the rest of your services don't fail? It's very common, especially in very young companies with very young architectural platforms, to have systems communicating with each other synchronously. And when that happens, once one system starts to slow down, that failure or slowness propagates, right? And it'll propagate up into your web servers, to your load balancers, ultimately TCP ports, get locked up, you can't handle more requests, your site's completely down. What we try to get people to do is to think about how to design either services or resource-based architectures that isolate those failures. So in your case, you might have a service, in Etsy's case, a checkout service or a market basket service, right? That only handles that specific flow, that specific action within the site. And should it fail, people can still browse, right? They can still look at items, they can search for items. Even better would be a further segmentation of your checkout services such that potentially they were aligned along catalog boundaries, right? So that should you have a checkout failure for some reason, capacity related or otherwise, associated with one set of items, it won't impact the rest of the shopping experience and the ability to check out. And that's really what swim lanes are all about. Many companies will call them partitions. Typically, we think partitions or shards have to do with databases themselves, the persistence tier down here, whereas concepts like swim laning or sometimes pods, as in the case of Salesforce, have to deal with taking that partition or shard and forcing it all the way back up as close to the user as possible, into the web servers, et cetera. Once again, ensuring that should you have transactions that start to respond slowly or that fail, you won't cause everything to fail. I have no idea what this is. I think Fish threw this in here to throw me off. Once upon a time, I was an electrical engineer, but I barely remember this stuff. The next concept within fault isolation that we want to discuss is the synchronous effect, or pardon me, the multiplicative effect of failures when you have synchronous calls across multiple devices. And this is really sort of showing that. If you remember back to, anyone remember Christmas lights? You know, the Christmas lights that should you get one bulb that burns out, the whole light, the string goes bad? Anyone here that old? No one, everyone else is like, no, we got perfect lights when I was a kid. So, and if you remember, you had to go through light by light and find the bad one. Anyone remember that? Okay, someone remembers that. That's what this is all about, right? Those are systems placed in series. When one of the systems fails, everything else that's communicating with it in a synchronous fashion is going to fail as well. And that's why we say, when possible, avoid systems in series. And taken to an extreme, that's the elimination of n-tier architectures to flatten them out into fewer numbers of tiers, right? Because you don't want to make the extra hops if you don't have to. If you can resolve something back to Fish's earlier statement about being lazy early, through CDNs or further up the stream, or proxies further down if you're going to use a public header in your cache, or in your, public in your header, that's what you want to do. Anytime you get synchronous calls in a series, your theoretical availability is a multiplication of all of the availability of each of those systems in that series of calls. Unless you communicate asynchronously, and you don't block on it. Lastly, and I think this is the last one, ensuring that whenever you roll out something, you can turn it on and off. And oftentimes we also say that you need to be able to roll back, right? One of the points in our book is you really shouldn't be playing in this game if you're thinking you're always going to fix forward, because that's where careers end. It's the big gotcha that you just can't fix forward from that kills companies and kills careers. You're laughing. It's true. He got fired.
He fired
yesterday. Yeah. Fish was never fired. He should have been, but you never know what's going to happen. Everything fails. You need to, in our business, especially when we're starting to talk about continuous releases, right? People deploying immediately, trying to get something out every day, you have to be able to get it back. Again, we think that turning on and off features and the ability to roll back are table stakes for the game. You can't subject your business to that type of risk.
Well, I didn't get fired for it. I have experienced this pain, and for those of you who have, you can sympathize that, if you can't roll back or get out of that situation and you need to fix forward, it can become a painful, shall we say, week or longer.
We both experienced it. The most painful time in my career was a release at PayPal where we had yet to implement the ability to roll back. And it was the longest, I would say it was longer than a week of my life. And there was no reason for it. It took us, once we had that pain, and we'd already experienced it at eBay. eBay would never roll code out unless you could roll it back. We had yet to sort of implement those processes at PayPal. It was the most painful week of my life. And honestly, we should have been fired because we knew better. We weren't, but it's another story. I begged for my job. Any questions? Hopefully. Is it going to be a hard one? Oh, Fish?
Yeah, it's for the Droid app for the book.
You give it any scalability-related problem, it will give you the answer.
It's an Android app for the book, so it's the 50 rules and the summaries, the what, when, why, how, for free. In case you're in a conference room or something, you can look it up.
All you have to do, it's got a little recording device on it. It listens to the conversation and recommends a solution.
That's in version 2.
Yes, they probably didn't hear you. I'll say it again. If you have questions, can you go to the mic? Anyone else got a buzz from the smell in here? Oh, Mike, you're violating the rules already. It's one of the rules of scalability. It's like Rule 7. Go to the mic. Face him.
So at a small company, it can be hard to prioritize scalability and these kinds of things over, say, new features or fixing other bugs and stuff like that. How do you recommend smaller companies get started, and sort of what's the order of operations here?
Yeah, that's a very good question. It's a very common occurrence within small companies that you favor very important revenue over availability and scalability. It's one of the most common things we see until it's too late. And very often, if you've got a great business model, you can work your way out of it. You can be resilient to those failures. Right? There are cases like eBay is a prime example. June of 1999 or July of 1990, before my time, they had fairly significant outages that last for several weeks, with very significant competition biting at their heels. They lasted through that, and I'm not even sure how, but largely based upon the business model and the community that supported, much like Etsy is today, the community that supported the company. But it's like any other investment, right? It's not the longer you delay it, the greater the pain builds up. That's why the technical debt concept is so useful in discussions like this. If you don't pay on your debt, which you incur, once again, at least in two ways. One is the growth of user transactions on your platform. And two is every time that you make modifications to your code. If you don't start paying on that early, then not only do you not address the principal, but the interest increases significantly. And it becomes much more and more difficult.
Yeah, so to sort of bring a story to that, we can share that we had a client who had been around about a decade and failed to pay technical debt. Got to a point where they wanted to bring on a big customer, and they asked them to add a second email column field. And their engineers came back with an estimate of 1,500 hours. So, yeah, 1,500 hours. So, that's how bad your technical debt can build up. And one of the tools that we typically teach our clients is what we call DID, which is design, implement, deploy. And so that's the concept that it really takes very little effort or time to sit in a conference room and design for scalability. It can take an hour, a couple hours, once a quarter. And we have a way, we have something that we like to basically sit in the conference room and ask the question of, what if we scale 10x? And for your company, it might be 100x, who knows? But, and you throw that up there and say, which of my components are going to have issues, and how do we design around that? And so it costs very little to do that. And then as you start to see that traffic start to come in, you now have to implement that. And then the fight, which actually putting it into code, is typically splitting up something, whether it's sharding your database or putting in an object cache or something. And then the last is actually deploying that, because you want to deploy it just before you need it, right? That's the most expensive from a hardware, from a maintenance, from everything. And so you time those that you typically design for 12 to 18 months out. You're implementing somewhere, maybe the 3 to 12 month, and then you're deploying within that very short window, depending on how fast it is, whether you're in a cloud service or a colo, how fast you can get hardware in there to actually deploy that new code.
And there are two rules that we've learned over time with respect to paying down this concept of technical debt. One, the first is that the business almost always thinks it should be less than you really need to pay. And the second is that in general, technology organizations always believe it's more than they really need to pay. If you start early, we've found over time through analysis within our client companies, that usually it's about 12.5 cents on the dollar as long as you're consistently paying that, right? So if you've got 100 engineers, if roughly 12.5 of them are associated with availability, scalability, maintenance type activities, and you do that consistently through the course of the year, maybe not for every release, but through the course of the year, generally the companies are fine. At the extreme, after you've had a lot of problems, very often companies won't make releases and it's 100%. Companies that get it in time but haven't been paying overtime usually angle up to about 25% of their development efforts to stay, and then they can start weeding it back down to 12.5 cents.
I mean, it's not uncommon.
Pardon me.
We can get off this question, but it's not uncommon to see companies that have to take entire releases or entire quarters to fix something if they get to that point.
And that's even more painful for a business than paying it over time. And if the concept of technical debt doesn't work, like because you're from Brooklyn or something, use technical protection, right? It's mob money. Thought that would go over better. It's funnier in my head. Any other questions?
I guess it's less a technical question, but from your perspective, so let's talk about like the cloud, right? Amazon. Do you think there's obviously people that leverage it smartly, like Netflix, which designs to fail, versus others who think that because they can auto scale, they might not necessarily have to pay a lot of credence to some of these things? Do you think the availability of being able to theoretically push a button and scale horizontally is leading to bad decision making, and I guess sort of like a general consensus about the state of it?
I think you're leading the witness. I think you're asking that because you know that many business people and some technologists think the cloud is some sort of magical thing, right? At the end of the day, they're real data centers somewhere with real servers in them, and they fail just as real as we learned with the most recent Amazon outage as anything else. And if you don't design appropriately, holistically, not just from a software perspective, but software and infrastructure, you're going to get failures.
Yeah, absolutely. That the auto scaling is a nice feature that you can take advantage of, especially to control cost. Right, the cost in the cloud can, as you really get to a large sets of servers, can get out of control if you're not policing that. And so the ability to sort of scale up and down dynamically and not have to have someone watching that every single day is nice. But that's not a panacea. It doesn't solve splitting the database or splitting up into services. As Marty said, right, there's if you watch Amazon's own status, stuff has problems all the time. And if your service happens to be on a region or something that's having an issue, whose fault is it? Right? It's not Amazon's. You really should know that as Marty said at the beginning, everything fails. Clouds fail, data centers fail. I can't count the number of times that entire data centers fail. And so you've really got to plan for that and know that it can happen, and then weigh the risk and say, it's likely to happen, so I'm going to have a backup plan. I'm going to be in another region. I'm going to be in another cloud provider. I'm going to be in a data center or something.
You haven't lived until you've had a chemical truck take out a data center. Like, that's not supposed to happen, right? You guys had one of those? Sweet. Living large, brother. Living large. Yeah, well, yeah, we were.
Yep.
Is the smell getting anyone yet? A little high? Well, we're having too much fun to sit down. Sure. Oh,
Hey, so most of the performance scaling techniques that I see people talking about have to do with optimizing, pulling data out, and avoiding going all the way back to the database.
yeah.
And the technique I've found for some problems works really well is pushing data out on change rather than trying to avoid pulling too far. And I was wondering if you
Sure, you're
wanted to
talking
talk
about
about-
once you know that you've made
Yeah.
change to data, pushing it out
Well,
rather than
yeah,
having a first request.
For example, years ago I did tvguide.com, and every time listings changed, we pushed out oceans of static stuff. So we never ever touched databases ever, and it scaled really well because the result was very stupid, right? All the work was on data update rate, which was predictable,
Yeah.
rather than on demand, which was not predictable.
Yeah.
But I never hear people talk about that kind of scaling, and I
Yeah.
was wondering if you
Yeah,
had
you
run
know-
into that and what you thought of it.
Yeah, I think it's a great idea. In fact, Yahoo, last I heard, has a cron job. Some of you can probably answer this. That literally takes a picture, just curls their homepage, wgets, so that they have that as a backup. And so, yes, there's all types of things in terms of trying to make this as static as possible that you can, and as you said, push that out to improve your scale, right? Instead of having to be dynamic, think of often, as we meet with clients and we talk about, the page is very dynamic. We ask, well, why does this part of it have to be? Why are you waiting to process that and build that part of the page? Why can't you, pre-process and push it out because it doesn't change for everybody? So yeah, absolutely.
Yeah, I think you could even envision an algorithm to help you make a decision as to when you should do that, like what's the rate of change, the number of endpoints to which you're pushing it, as compared to the rate of request, right? And then once it would be pretty simple, plus some complexity of actually having to push it out, it would be pretty simple to decide when you should push it out.
The other reason I've run into it is around timing lists, like say a product price changes and you don't want caches to time out for an hour.
Yeah.
You just want to push it out. Is the other angle. So,
Yeah.
Thanks.
Yeah, thank you. Sure.
Hello, fighter pilots. I have two questions. So, for your
Hello.
for your command and control, what's your preference for monitoring tools like Munin or other things? And the second question is for data-centric applications, have you ever experienced with any of your clients code as well as data that needs to be upgraded and rolled back, and any horror stories there, bloodbaths?
With respect to the first question, we think you can make any system available and scalable, right? Especially monitoring systems, because ultimately they're subject to the same problems that any other application is, and you're going to have to, at extreme scale, start splitting them up. Systems like Nagios, et cetera. Expecting them to work in a monolithic fashion when you know that your own software or code base and systems can't is a recipe for disaster. And we really don't recommend specific tools. We're agnostic. We think you should take a look at what your skills are within your organization and make sure you have a match for the tools that you want to deploy or employ. And that's probably the most important decision, especially with respect to operations tools that you can make. I don't know if you want to.
Yeah, the only thing I would add is that you're actually sitting in the offices of someone who does this really well. So right, Etsy's very operational in terms of if there's an issue, turning around and monitoring that, and you've got a dozen people here who could expand on that. So there's certainly teams out there that do this really well. The one thing that we see with monitoring, though, is that we think is a mistake is we typically see it starting from a systems level. And you start monitoring disk, and you start monitoring memory. And, that's great information, but if you've architected properly, that does not tell you if there's a problem, a user problem, or what the ITO would consider an incident. So you need to monitor business metrics to know that there's an incident, to know how to respond to that blinking red light. And so that's one of the things that we typically see people do in reverse is really you need to know whether there's an issue out there first, and then have the ability to drill down and find out what's causing that.
I don't
Just,
remember what the second question was.
I just want to say, so my favorite business metric that we monitor at Etsy is we measure the rate of posts in our community forums, because generally they freak out first, and then the rest of the alert systems go off. So it's a great
That's
business
actually an
metric.
incredible one. That's a great idea. We're going to steal that, and he'll be part of the next book. Did we offend somebody? Any other questions? Oh, no, they're clapping for you. Clap for you, brother.
It's people. A lot of these, we're talking about teams and systems, but a lot of these decisions are made by, individuals at 10 p.m. with their headphones on. There's like individuals making decisions that then scale or don't scale, sometimes on their own. And they're engaged in a creative act. They're not coding with the team and going through operations. And it's a kind of a soft question, but I was wondering if you have any suggestions on, the best ways to kind of lightly evangelize to your developers. You have like rhymes,
A rap, maybe?
Mnemonics,
Maybe a rap song?
But seriously, they don't want to be, they might not want to be thinking about these
Yeah.
things. They just want to create.
Yeah.
But you're trying to find, I was wondering if you guys think about ways to get into these developers' heads to create habits, which is something they might like to learn at the time that they're with you at the company.
Well, I think it's critically important that individual contributors within a company, whether they be engineers or marketing people or some other business group, that they understand first and foremost the mission of the company, the values of the company, how it is individually that they help create revenue and value for shareholders. That's why we're all here, right, at some level. And that helps guide people's approaches and opinions, and then within and the way they do their work. Within technology organizations, having a set of principles that help guide exactly how they do their work, right? So how it is that you're going to scale. One of them might be scaling out rather than up always, so that people are asking themselves as they're coding or as they're developing systems, the system that I'm employing or deploying, does it scale out, or have I done something that implicitly relies on the system getting bigger and bigger over time?
So, yeah, two thoughts. One, whoever brought up the military, now I've got it on my mind. So yeah, from the military, in what's called an operations order, which is basically a big plan for a mission, there's a commander's intent. And so the idea is that if you simply give at the beginning the intent of the commander, what are they trying to accomplish, then even if everything goes to hell, at least the soldiers on the ground know what the intent is of the mission and can improvise and adapt and hopefully overcome. And so I think similar to that in technology and business, they've got to understand how what they're doing creates value. And so you should any engineer, any person in the technology organization should be able to say, what I'm doing and how that affects the business metrics that are driving, revenue. And then to make it more specific, we typically tell people that they need to adopt, scalability principles. That, things like, we're never going to deploy singletons, and, we're shooting for commodity hardware, and, things like this. And I think the way to get the buy-in is, instead of giving it to a team and saying, these are our principles, now everyone obey them, is have the team build them, right? You can certainly seed it with some ideas, but If the team comes up, together jointly, then they're certainly going to be more bought into that.
I think with that, I'd like to thank Marty and Mike and give you guys some time to mingle and buy some books and have some beers. Thanks, Marty. Thanks, Mike.